Oh, yeah, I think so.
Are developers. We are developers. I didn't. Oh, look, I have a slide clicker. Yay! How are you supposed to say that? Is it like we are developers, or is it we are developers? Which is really like we are developers. Why don't you believe me? There's also the Star Trek version. Damn it, Jim, we are developers, not doctors. Are any developers in the audience? Any of you? Any of you? Raise your hand if you're a developer. Okay, no, keep them up, keep them up. Keep them up. 1, 2, 3, 4, 5. Okay, 8. That's good, because being a developer is awesome because you're writing software. Software is everywhere. The whole world is full of shitty things that have computers in them that are running software. And software, as Mark Andreessen said, is eating the world, which is great. And developers are the famous, amazing people that are writing that software. So that's you. So that's good. The software is eating the world is actually really incredible. I mean, I have a Japanese toilet that has more computing power in it than the entire Apollo 11 space program. It's literally just everywhere. Okay, does anybody have salt at home? You know, like a salt shaker? You have a salt shaker? Yeah, what's your name? Jürgen, you have a salt shaker. Yes, does it have Bluetooth? No? Jürgen, what is wrong with you? Are you from the past? How do you send music to your salt? USB. Yeah, sure. Okay, so this is the reason I think developers are so awesome, because developers are writing code, and the code runs in like the entire world, and software is eating the world, and we are writing the script for the future, so that's why you're like the most important people ever, so give yourself a round of applause. For writing the script for the future. Okay, awesome. Now, how's it going? No, not that. I mean, how is the writing of software going? Is it easy, hard, fun, frustrating? Is it getting easier or harder? Easier. What? It's getting more and more complicated. Software is doing more and more things. It's becoming more complex. There's definitely cool tools that are making it possible, and that's sort of what I'm going to be talking about today. But I think today, when I look at what is involved in software development, it is actually more complicated and more complex and more error-prone and more difficult than it has ever been before, because of the complexity and the richness of things that you can do and all the kind of stuff that you have to deal with. And our brains are kind of staying the same. Not mine. Mine is getting worse. And the way that we deal with this is through abstractions. We create abstractions that make our life easier at the same time as the tasks are getting more and more complicated. What are abstractions? Well, you could have a library. You could have a framework. You could have what's the difference between a library and a framework, by the way? A framework is a library with an army. That's the official definition. You could have like an entire web service that you access on the web and does things for you. And these are all abstractions, and they're ways of making things easier. So that's sort of the two parts of my talk today, I think, are about how software is everywhere. It's eating the world, and we developers are creating it, and therefore writing the script for what will happen in the future. And also that we have to deal with abstractions all the time. And these are two things that Stack Overflow is here to help you with. So let's start with this software is everywhere. The simplest example of software kind of getting in the way of every single thing is just the on-off switch on a computer, which is that this is an IBM PC, and when you turn it off, that's the big red switch in the back and the button. What happens? The electricity goes off. And you're physically disconnected from the electricity. Electrons are no longer delivered to the computer in any way, shape, or form. And this is, of course, ridiculous and obsolete. On a newfangled computer, you have an on-off button, and that's just a button, and the button just like runs some code. And the code's like, oh, I'll send notifications to the daemons, and we'll ask all the programs if they want to save everything, and if they want to shut down gracefully, and all that kind of stuff. And And then we won't really go off. We'll just go into sleep mode. And in sleep mode, your laptop is still using electricity. It's using more electricity than the entire 17th century, but it is off as far as you're concerned. And that's an example of software eating the world. Here's like another example. I mean, you see this everywhere. This is an airplane. This is a DC-3. It was built in 1935. And every single steampunk gauge in there is a real thing. So you pull back on the yoke, and it pulls a little wire, and the wire is connected to the elevators on the tail, and they go up, and then you pull back, and the plane goes up. And it's entirely a physical operation. And obviously, on a modern airplane, all you have is sort of the Facebook user interface here. It's like all electronic and glass screens, and everything is connected to a computer. And every single button that you see there is just an input device, and every screen is an output device, and there's a computer that's actually flying the airplane, making the announcements. Anyway, instead of you don't even have, there's a little joystick, like a game, like literally a game joystick that you could use, I suppose, but mostly you just sort of type destinations on the keypad and the plane flies to them. I'm not even joking, that's literally what happens. And this is sort of what I meant. Everything is that way. You used to just have the simplest thing like an alarm clock, which you do with your phone now. You could have the act of sending a letter to somebody, which obviously has been online for the longest time. You used to like raise your hand and a taxi would stop. You have to whistle. You raise your hand and you whistle, and a taxi would stop. Nowadays, kids do not even know how to whistle. It's not a skill that has to be taught in schools anymore, because you get a taxi on your phone, and you pull out your little iPhone, and you're like, boop, Uber, boop. Where do you want to go? Okay. And then like a little map shows up, and it shows your little car dancing, a little picture of a car. It's so cute. You can watch it come closer and closer and closer, and then it cancels the ride, and then another car comes. It's like, you see it sort of like turning around in the street and driving sideways and driving backwards. And that's Uber. There's this new thing. Have you had this thing happen with Uber? It's kind of not the ideal experience, which is that the driver calls you, like on the phone with the speaking, and he's like, "Hello, it's your Uber driver. Where are you? I'm at the airport. Where do you think I am? Taking a bath? Okay, I'm coming to get you." I know, that's exactly what the application does. Anyway, yeah, so Uber is a thing, and this is software eating the world, and the sort of metaphor is that we're living in this soup of software, not a very thick soup, but it's just everywhere, and we're just little floating vegetables in there. We tell the soup things, and then the soup does them. It tells the other floating vegetables what to do, or another way of thinking about it is that we tell the software what we need, and the software probably bosses around some human being somewhere and sends them somewhere. Think about what's going on in an Amazon warehouse. Like every single day, it's just these big, long rows and rows and rows of stuff. And there's little human beings milling around in there, and they have no idea what they're doing. They have a thing strapped to their wrist, boop, like this, the computer strapped to their wrist, and it tells them exactly what to do. And it just says, it makes a little map. It's like, go over here, go to this shelf, take this thing down. They don't know what the thing is. It's like a little piece of some rubber garbage made in China. They don't care. They have no idea what is in that thing, and they pack it in a box, and they have no idea where it's going. That's just all they do all day long. And that's sort of like an output device, really, when you think about it. So the worker in the Amazon warehouse is just an output device. You had input devices, you get keyboard, mouse, I don't know, brain sensor. And then you have your output devices. You got your line printer, you got your screen, you got your Amazon worker. Those are your output devices. In fact, I thought it would be kind of funny to try to get a job at Amazon, like a developer job at Amazon. Not just any developer job, but I want to get a job as the person that writes the software that sends the warehouse workers around. And I'd quietly do my job normally for a long time. And then, on my birthday, at 8:30 a.m. Central Time, all of the workers would suddenly go outside on the lawn in front of the warehouse, and they would spell out my name in gigantic letters. Because you can do that as a programmer at Amazon. You can do that. If you did that, Jeff Bezos would come to your house personally and cut you in pieces and throw the pieces on a fire But you can do that, and it would be sort of amazing. Now, the actual people, not me, the actual people who write the code that drives the workers around the warehouse in an Amazon factory, one day they noticed that the human beings they were sending around were sometimes short. And if they were too short, these human beings could not reach the items on the top shelf. And so what they would do is they would stop and they would go look for a ladder. And then entire minutes would elapse, during which nothing appeared to be happening. And this was a problem. And so they actually decided that they could fix this. You could put ladders everywhere. Little step ladders on every aisle. They decided, let's fix this in software. So what they did is got a database from Human Resources. They probably connected to the database, which has the height of every worker in every Amazon warehouse. And if you're a short human being, you never have to pack any boxes that include items from the top shelves. It's pretty cool. And after they deployed this software, Amazon became 0.001% more efficient, I think, which is amazing. And actually, it's either extremely humane and wonderful to think about kind of that human way that they made things better. It may also just be like really evil. I don't know which. You can decide for yourself if that's sort of utopian or dystopian, that we sort of squeezed out that last bit of inefficiency. Not really last. That's sort of happening all the time. All this software is changing the world. Software is a script. This is just a metaphor. Like Amazon, it's not really. I'm bringing it up as an example. But this is happening everywhere in our everyday life, and we're maybe 10% of the way there. It's going to get much worse before it gets better in terms of how much we have to go through software to do any of the things we need to do. And that software is written by us, by human beings, and then it runs in the future. And that is why software developers are writing the script for the future, and that's why that is the most important job in the world. Now, why do you want to stick software in between the power button and the electricity? Or why do you want to stick software in between the pilot and the airplane? Or why do you want to stick software in between the people and the factory and the warehouse? It's because you have an agenda. There's something that you want to do better, let's say. I don't know, better is a judgment term. You just have an agenda. You have some kind of agenda. What are some examples of software agendas? Amazon wants to make their warehouse as efficient as possible. So the person writing that software is trying to save money by hiring fewer human beings and making the ones that you already have work harder. Uber is trying to create more efficient transportation. They're trying to figure out how to get you to where you're going quickly. And they have other agendas, right? Like Uber is probably trying to keep the Uber drivers feeling happy so that they don't quit. There's a whole bunch of different agendas you could imagine. And that's why they write their code, and that's what they think about all day long. What's the agenda of Facebook? This is important because this is the software that is used by more people than anyone in the world. I think I gave it away here. Facebook's agenda is to make you look at a lot of ads, which are delightful. They know that you will enjoy the ads, and so they want you to look at as many as possible. They do this by keeping you engaged in the site. And engaged is a word that the user experience people sort of invented to mean clicking on the like button, or really clicking on anything. As long as you're clicking, that's what's important, because that's the only sign that we have that whatever the heck it is at Facebook that we're doing is making you happy or something. At least it's making you engaged. I want to tell you like a Facebook story. Once I called up my best friend and said, do you want to go out tonight? And he's like, I'm busy, and I'm really tired, and I have open heart surgery tomorrow. I'm like, OK. So we didn't go out, and that was fine. The next day, I log on to Facebook, and there I see my friend having a great time at the very party I wanted him to go with me to. And Facebook ratted him out. He was not busy. He was clearly not having open heart surgery in this picture. Open something. Anyway. And then I realized that he didn't like me. I don't even know why I was friends with this person. So he didn't like me at all. And then I was sad for 3 months. And what the heck was Facebook thinking? Well, it's obvious what they were thinking. They're like, oh, you're friends with this person. There's a picture of him. I will post it. You will like that because there is a 3.2% chance probability that you will click on the like for this picture based on our machine learning algorithm. Whereas there's only a 3.1% chance that you will click on that quote about how bad Donald Trump is. So this is 3.2 instead of 3.1. I'm going to show it to you. And Facebook doesn't know any better. It doesn't really care. And we keep saying, what was Facebook thinking? It's not even thinking. It's running machine learning algorithms, essentially, which are no more than a bunch of matrix multiplication. So stop thinking of Facebook as doing anything reasonable. They just want to get you to keep using the site as long as you can, and there's really nothing you can do about it. Subliminal message. They did a study. I don't know who. Academics did a study with Facebook. So this is a collaboration between a group of academics and the Facebook company. And they asked like 1 billion people, 689,000 people. They didn't participate. They were caused to participate in this study, Facebook users. And what they did is they took some subset of these people and showed them happy stories in their newsfeed. And they took another subset of people and showed them sad stories in their newsfeed. And it turns out, what they discovered was that when you show people happy stories, they are likely to become happier. Wait for it. And when you show them sad stories, they're likely to become sadder. And I said, shocking. What did you actually think was going to happen? Like anybody could tell you that. And now they're academics. So instead of saying sad stories make people sad, they wrote emotional contagion. And we kind of all know what was happening. Now, the next super shocking thing, wait for it, is that after they published this study, everybody got really angry at Facebook. And there was this whole thing of saying, you did not have permission to do an experiment where you manipulated people's emotions. That is absolutely absurd. You're not allowed to manipulate people's emotions for the purpose of an academic study. And I thought to myself, every single day, Facebook manipulates what goes in the feed in order to get you to click on more ads. So what do you think they're doing the rest of the time? On the other 1.5 billion users, besides those 600,000 people who at least some of them got to see happy stories. There was kind of a time when people thought that social networks were going to be these harbingers. Okay, I don't know that word, so I can't use it. There was a time when people were talking about how great the social networks were, and they were going to create like a revolution in Iran through Twitter, and everybody was going to get organized in social media in Egypt and make another revolution there, and it was going to be amazing. The social networks were going to bring democracy, beauty, and utopia to the world in some way. Sounds excellent. Now, I'm old enough to remember, I'm not really, but I'm old enough to have read in a book, which you can too. I read in a book that when television first came out, everybody said, oh my God, television, this is amazing. A professor at Harvard University can give a speech and it can be broadcast to thousands of people all over the world with every color and race and creed. And a bricklayer in Pakistan could learn molecular biology from a Harvard professor. And that's what television is going to be like. And of course, if you turn on television, it's like the Kardashians and the Donald Trump. So, and the same thing obviously happened with social media, although what happened with social media is it's much worse. With social media, we got everybody only seeing the things that make them click. Because that's what the algorithm does with all that matrix multiplication. It tries to get you to click on things and be engaged. And it's okay. It's actually not okay. Because what's happening is the people on the right wing of the political spectrum are only seeing what right-wing facts. They're not facts. It's made-up bullshit. Like, half of it is just false. It's like, you're not going to believe this. Wait a minute. You're not going to. We have now elected in the United States a person who posts as president of the United States, 4 lies a day on Twitter, big lies, and like 11 small lies. But like 4 big lies a day to Twitter, 11 small lies. And that's what we get, and that stuff gets forwarded like crazy. All the false things and stories that don't make any sense, and stories that are just ridiculous partisanship, and things which are just sort of extremely biased in one particular version or another. And we used to have another word for this, which is propaganda. Now, propaganda, I don't know where this word went. It disappeared. And we used to think, oh, don't worry, that's like Soviet Union stuff. They only had one newspaper, and nobody was allowed to buy a typewriter. So we could not ever have propaganda again because we have 500 million news outlets. Everybody with a Twitter is a news outlet. Every little egg can make up whatever fact they want. And we've created sort of, we're back in kind of a world of propaganda, where if you try to get your news from the Facebook and the Twitter, their algorithms are showing you things which are going to make you believe what you already believe. And the thing which gets the most clicks, the algorithms have discovered, is righteous indignation. Anything that makes you smug and angry at the same time will cause you to forward it. Does not have to be true. The baloney stuff that makes people angry and smug and righteously indignant gets spread around the world really, really fast before, as they say, the truth has a chance to get its pants on. I just made up this quote. And that's not very good, because software is eating the world. Nom, 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 nom. And so that's sort of a non-ideal situation. But we can do something about it, because what are we? Developers. And we're writing the script of the future, and so we can sort of fix this. So let's talk a little bit about scripts, shall we? This is the code. Since you're developers, I'll tell you what it does. This is a spell checker, but not any spell checker. This is a spell checker that uses the entire corpus of the internet to find the most popular words and actually spell check based on the words that people are empirically using on the internet, not just look things up in a dictionary. It's not a lot of code. It's Peter Norvig wrote this at Google, and it's sort of kind of pretty amazing to show sort of the power of Python. But anyway, that's code. That's what code is. What is every piece of code? Every line of code consists of a bunch of decisions that were made by developers. If you call a function, and the function takes 4 arguments, you just made 5 decisions, right? What should those arguments be? They're tiny, but they add up, right? Because you write lines of code every single day, and everybody in here is writing lines of code, and all that stuff collectively adds up to a heck of a lot of decisions about the future. And the people that think that they're making those decisions, i.e. our bosses, i.e. managers and people like me, could not possibly make every decision that you all have to make. You're making 98% of the decisions, and they're making 2. So that's, again, what I mean when I keep saying developers are writing the script for the future, is that you're literally sitting there, you're literally writing that code, and the code is going to run not in the past, but in the future. Now, as I said earlier on, this turns out to be really, really hard, and the abstractions help us make the code a little bit better. Has everybody ever know what this is? This is VisiCalc. There's like one old person. VisiCalc was the most popular software program of the 80s. It was astonishing. It sold millions of Apple IIs. This was the state of the art. Every business person in the world had to have this program, and that is literally what it looked like. And you could write it today very easily. But this ran on the Apple II, and the Apple II had a MOS 6502 processor. And the 6502 processor, just so you know, could not multiply or divide. It had addition and subtraction. Subtraction, I'm not allowed to say that word either, am I? It could add and it could subtract, but it did not have multiplication and division. So if you wanted to divide 2 numbers, you had to stop and write code in assembler to do that, which was amazing, but that was the state of the art for programming, and it seemed very simplistic. It was already kind of useful to people. When I first got to college in some year, it was the first time I found a Unix computer. They had a Unix time-sharing system, and you could go to the library and get these 2 books, Kernahan and Ritchie and the Unix Programmer's Manual from Bell Labs. And you could read those 2 books, and at that point, you knew everything there was to know about programming this computer. Let's say it's Unix running on a PDP-11 or whatever. You knew it all. You were done. There was no other stuff there to learn, and this is kind of all you had to learn. And so becoming a programmer was deterministic. It was fairly easy. Let me tell you another story. Let's say, for example, just sort of to compare the 80s to today in terms of the power of the software that you could write and how useful it would be and how high the abstractions were. Like, let's say it's 1983, and you have a store, and what does your store sell? Well, it's 1983, so you sell Rubik's Cubes, 'cause that's all anybody bought in 1983. Okay, that's your store. Now, what do you do with your computer? You just bought a brand new TRS-80. It's got level 1 basic. It's got 4K, of which I think 2.6 are consumed by the basic interpreter. So you got 1,100 bytes or something that you can use for your own program. And you write a little program that prints out on your line printer a list of all the items that you have in stock and how much sales tax to charge for them, something like that. So it does like a simple multiplication. Amazing. That's what you would do with a program in 1983, and you would be done. Now, today, this is never going to be a program, and we're not going to print anything. It's going to be an app. And what kind of app is it going to be? It's an app that finds the nearest Rubik's Cube store to where you are. And so we're going to start by using Google Maps, and we'll just figure out your location and display a map. And then you need to go to the Rubik's Cube store, so we're going to call Uber, and a car will come and pick you up. And then you need to pay for the use of the app, and we're going to go ahead and just use a line of code with Stripe, with their API, and it's going to charge us. Think about the insanity. This is 12 lines of code. I'm not kidding. Like, everybody here, if you had to, could finish this before dinner without even getting a little bit shaky. This app, think about what it is now doing, okay? It's displaying a map with Google Maps, which is already insane. I mean, where did those maps came from? They came from satellites in space that took pictures of the entire Earth at high resolution, and you can call upon them in a millionth of a second without even knowing how any of them work. And then it calls Uber, which summons a car, and the car arrives, and it causes a driver to call you and then drive towards you, hopefully, and get there. And I don't even want to talk about all the software that is running in his car, right? Like, that's the onboard computer of the car, and the driver from Uber actually comes in. And it's like, really, when I was a kid, you were lucky if you could make a picture of a car move across the screen. But this is a real car that comes to you. And then the payment system, oh my God, when you charge that person's credit card, 95 billion lines of code run. It's not a real number. Lots of code runs all over the world. Stripe works in 170 countries, and I didn't even know they had that many countries. And it's like 12 lines of code. It's sort of amazing. I mean, 12 lines of code on an Apple II, you could divide to 8-bit numbers, as long as they were 8 bits, and there was no negative numbers or... this is You All Had a Talk by Hope and Lee this morning, right? Sorry, we love CSS, but it's really complicated, and it's super hard to keep track of all the things that are going on with CSS, and that's sort of... Is he still here? Raise your hand if you're Hokum Lee. Sorry. No, I love CSS. However, if a car used CSS as a user interface, you would turn the wheel to the left, and you would go to the left. And you would turn the wheel to the right, and you would go to the right. And if you tried to drive straight forward on the center, the car would disappear. I don't know why. It's gone. It's like, CSS was never very good at center. And so that's what you're using, an abstraction which you don't understand. You know, the web browser, the CSS engine, the layout engine. It's an abstraction which you just learn left, right, center, and center doesn't work. And similarly, all right, so that code that does the Rubik's Cube stupidity, it's displaying a map. How do you display a map with Google Maps? Well, here's some code that displays a map with Google Maps or something. And then you discover that when you display the little map, that sometimes people like accidentally touch it with 2 fingers and it like zooms in or zooms out. And you're like, no, never want to do that. I need to disable the scrolling capability. And you see there's like a little command line argument there called scale control, and you're like, I wonder if it's that. So you set that to false, because that's just like right in front of your face. And you try that, and that doesn't work. And you say, oh, now I'm really stuck. What are you going to do? I don't see anything else on that code that I copied from somewhere. Now you could buy this book. And it's 460 pages. And it will teach you all about Google Maps. And if you're very, very lucky, having waited for this book to arrive 3 days later, you would find out what you did wrong and read 460 pages, and you'd be able to fix the problem, maybe. Or you could just search on, oh, what is that thing called? Stack Overflow. One forgets. And if you're lucky, you'd find the answer is probably already there, and it would solve you with this problem. So sort of actually kind of one of my key observations today is that what Stack Overflow is doing right there is helping you with an abstraction. It's allowing you to program at the layer of one line of code displays a map instead of having to make satellites and send them into space. And that's why it works. Jeff Atwood and I built it in 2008. We thought it was going to work. We didn't know how successful it was going to be, but we really wanted to. And the thing that we really didn't know is just how important it was going to be to allow programmers to move up from the old school programming of using Kernahan and Ritchie and just only doing things that appear in that book to the new school where in the morning you're talking to Uber, in the afternoon you're talking to Amazon, and 20 minutes later you're talking to Stripe, and what did I leave out? Google Maps. And you're just using sort of one line of code from each of these things, and there's a huge abstraction below that, and you cannot possibly learn it, but people can help you with it. And this caused Stack Overflow to get to the point where it's now on the top 30 websites in the United States, which is insane. Like, it's just programmers using it. It's only developers. They're using it. Every developer in the world is using Stack Overflow up to, on average 7 times a month. Probably a lot more than that. And there's a business model. People are like, hey, how do you make money? Well, I'll tell you. Actually, let's look at what makes Stack Overflow work, and because that directly relates to how Stack Overflow makes money, which directly relates to developers writing the script. OK, wait a minute. I'll just give you the speech. I don't have to tell you about it. OK, when you ask a question, an answer appears, but all those questions and answers get voted on. They get upvotes, and those votes lead to reputation. And you're like, I don't care about reputation. That's stupid. It's just internet points. But they're sort of important internet points because they show that you know something. They show that you know a thing or two, and they demonstrate to the world that you've answered a few questions, you've helped a few people. The number of people that you help is an extremely important metric to us, so it's right there in bold print on the top right is the number of people that found your answer following some complicated formula and hovered or something, or I don't know. But it's a number of people that you've helped, really. Stack Overflow is this gigantic helping experience whereby us poor developers collectively in this room who are having trouble with the Google Maps API and the Uber API, they help us essentially deal with a world of terrible complexity and the difficulty of programming, and they allow us to work at a higher level of abstraction than we could when we just read one book. And that reputation feeds into a thing that we call a developer story, which with one click you can go create for yourself on Stack Overflow if you don't already have one. And the developer story is meant to be a bit of a narrative of your professional career. What did you learn? What do you know? Where did you work? But also, what questions did you answer on Stack Overflow that got 1,000 upvotes that you're super proud of? What blog posts have you written? What books have you read? All the stuff that adds up to what you think an employer might want to know about how awesome you are, so they might want to hire you, and you might get a better job. And that's really the other part of my mission. The other part of my mission is every single one of you using your Stack Overflow profiles to go upgrade your job by 1, if not 2. And in fact, if anybody here doesn't have a 27-inch Retina monitor, at least, if not 2, a really comfortable chair like a Herman Miller Aeron, a desk that kind of moves up and down so that you can stand up sometimes and you just have everything at the comfortable height, and quiet working conditions, like please do not interrupt me and do not make me sit next to a person who is on the phone doing sales. Love salespeople. Don't want to listen to them. That's the minimum requirement for a developer, and I want to upgrade everybody. Every single person needs to get at least that level of jobs, and so we built Stack Overflow Talent, where you take your Stack Overflow reputation, which is optional, by the way, but it helps, and you don't need a lot of Stack Overflow reputation, by the way. You need to answer like 3 questions so that the employers can read those answers that you wrote and say, wow, this person is really smart. And we take all that, and if you give us permission, if you don't care, fine, just check the box that says you're not looking for a job. We actually show that to recruiters, and not just any recruiters, but actually companies that are hiring developers. So you don't get sort of stupid spam messages. You get messages from actual companies that are looking to hire developers, and that's really the Stack Overflow business model. So that brings it all together, right? The first part, developers are writing the script for the future. They're super important. They're the talent that matters. And oddly, they're not getting treated like that. They're getting treated like typists who have to sit in dark, satanic mills typing away. And so we get them better jobs. And the other part of that is that writing the script for the future is getting harder and harder. It's getting more and more complex. And you're using higher and higher levels of abstraction, which make it easier. And that's how we keep at the same level of the human brain, which is not evolving nearly fast enough for me. And then we get you better jobs. And then you sort of use that knowledge that you've sort of developed through Stack Overflow to get better jobs because developers are writing the script for the future. So there's sort of two themes all come together. And our slogan at Stack Overflow is the three things you can do on Stack Overflow. You can learn, you can share your knowledge, and you can level up. So software is eating the world. It's going to be everywhere. We are only, at best, 10% along the journey of just how bad it's going to be when every single thing you try to do, you're actually interacting with software. When every single company that you call, you're just calling a person with a web browser that has all the same access to all the same things as you do on the website, only shittier. and giving you bad customer service because they can't fix anything that a software developer has not made possible. So the world is getting more and more complicated. The software is getting to be everywhere. You all are writing it, and every single day in the future is going to just be determined whether you're happy or sad or successful or productive or whatever of every poor human being on this planet. I meant sad, whatever, not rich human beings too. It's going to have to use all the software that you people write. So please do a good job of it. Thank you very much. Thank you.
Thank you. Thank you very much.
Thanks.